Hello again. This is our tutorial about moles and molar mass, so we're going to talk about understanding moles. Firstly, we're going to talk about what is the definition of a mole, and then we're going to talk about what is molar mass, and then we're going to do some calculations of masses and reactions using our moles and molar mass. So firstly, what is a mole? Well, when we look at a chemical equation, we can see how many atoms or molecules react with each other, the ratio they react. And we can also see the number of product atoms or molecules too. But in real life, we don't react individual molecules. They're just much too small. If you remember, we said that up to 1 million atoms will fit across the cross-section of a human hair. So even a tiny amount of reactant in a beaker or a test tube, the smallest amount you could see, would contain billions of atoms or molecules. So in the real world chemistry, we need a different unit of substance for our calculations. We still need to be able to compare the number of particles though. And by particles we mean atoms or molecules. We need to see how many of those are reacting with each other. We know the ratio, but we need to know how many. So why don't we just use mass? That's quite easy. Well, atoms of different elements can have very different mass from each other. So just for an example, if we're comparing 1 gram of hydrogen and 1 gram of oxygen, we can see that it doesn't work. So hydrogen has a mass of 1 and oxygen has a mass of 16. So there are 16 times as many hydrogen atoms in a gram as there are oxygen atoms. So using mass doesn't help us compare the number of particles reacting. We do need to compare the number of particles. We need a unit that's based on the number of atoms or molecules that are present. And that unit is the mole. It's the international unit for the amount of substance, like we have international units for all sorts of things, kilometres, kilograms, all sorts of things. Our mole is equal to the number of atoms of carbon in exactly 12 grams of carbon-12. So this number of atoms is referred to as Avogadro's number, because Avogadro's number is a big number. It's 6 times 10 to the 23. So there are 6 times 10 to the 23 atoms of carbon in 12 grams of carbon-12. And that's what 6 times 10 to the 23 looks like when written out. So you can see it's a huge number of atoms. So what's molar mass? Molar mass is the mass of 1 mole of a substance. It is the relative formula mass expressed in grams. And relative formula mass is also known as gram formula mass if you're studying National 5 syllabus in Scotland. So what is relative formula mass or gram formula mass? It's abbreviated to RFM, you'll see that quite a bit. It's the sum of all the atomic masses in all the atoms in a formula. So we just add up the relative atomic masses of each atom in a chemical formula. So, for example, oxygen O2, we can see that the relative atomic mass of an oxygen atom is 16. There's 2 atoms of oxygen, so the relative formula mass is 32. And the molar mass is therefore 32 grams. Another example, ammonia, NH3. So our relative atomic masses are 14 for the nitrogen and again 1 for the hydrogen. So if we have 1 nitrogen and 3 hydrogen atoms, the relative formula mass is 17. And the molar mass is 17 grams. Another example, our water molecule H2O. So our relative atomic mass of an oxygen atom is 16 and hydrogen is 1 as we already mentioned. So 2 hydrogens and 1 oxygen have a relative formula mass together of 18. That's the relative formula mass of our water molecule. So the molar mass of water is 18 grams. 1 mole of water molecules is 18 grams. Another example, sodium hydroxide, NaOH. So sodium has a relative atomic mass of 23. We've mentioned oxygen and hydrogen already. So one atom of each gives us a relative formula mass of 40. So a mole of sodium hydroxide molecules is 40 grams. Another example, a bit more complicated, calcium carbonate. So our relative atomic mass of calcium is 40. Carbon is 12 and oxygen is 16. With 1 calcium, 1 carbon and 3 oxygens, we have a relative formula mass of 100. So a molar mass, 1 mole of calcium carbonate weighs 100 grams. And another example, final example we're going to look at is sulfuric acid, H2SO4. So sulfur has a relative atomic mass of 32, and we've mentioned hydrogen and oxygen already. So with 2 hydrogens, 1 sulfur and 4 oxygen atoms, the relative formula mass of an sulfuric acid molecule is 98, and the mass of 1 mole of sulfuric acid, its molar mass, is 98 grams. So how do we calculate mass from moles? Let's say we have a question where we need to calculate the mass of X moles of a substance. So step 1 is to calculate the relative formula mass of the substance, like the examples we've just looked at. And then we would convert that into a molar mass by expressing it in grams, like in our examples too. And then we just multiply the number of moles by the molar mass. So an example, hydrogen, 1 mole of hydrogen. So the relative formula mass is 2, the molar mass is 2 grams, and our mass is 1 times 2 because we're looking at just 1 mole, so that's 2 grams. Another example, 0.5 moles of sodium chloride. So the relative formula mass of sodium chloride is 58.5, so the molar mass is therefore 58.5 grams, and 0.5 moles is 29.25 grams. Another example, 2.35 moles of aluminium. So the relative formula mass of aluminium is 27. So the molar mass is 27 grams. So the mass of 2.35 moles is 2.35 times the molar mass, and that gives us 63.45 grams. How about a question where we need to calculate the number of moles in X grams of a substance? So firstly, we're going to calculate the relative formula mass and the molar mass, and then we're going to divide the sample mass, the number of grams we have, by the molar mass that we've just calculated. Let's look at a new example. So the number of moles in 24 grams of oxygen. The relative formula mass is 32. The molar mass is 32 grams, so we divide our 24 gram sample by 32 grams of molar mass, and that gives us 0.75 moles. Another example, the number of moles in 5.8 grams of magnesium sulfate. So the relative formula mass is 120, molar mass is 120 grams, and the sample mass was 5.8, so the mass of the number of moles is 5.8 divided by 120, which is 0.048 moles. And another example, the number of moles in 75 grams of ethane. Ethane has a relative formula mass of 30. The molar mass is 30 grams, so 75 grams is 2.5 moles. So what can we use moles for? Well, we can calculate the amount of reactants needed in mass or moles, and we can calculate the amount of product produced or expected, again, in mass or moles. So for example, a typical exam question where we would calculate the mass of a reactant. So here we are, a student wants to make 15.0 grams of copper chloride by this reaction. We have these relative atomic masses given. So we need to calculate the mass of calcium carbonate that the student should react with hydrochloric acid to make 15 grams of copper chloride. So we're calculating the mass of our copper carbonate that is reacted with excess hydrochloric acid to make 15 grams of our product copper chloride. Firstly, we need to calculate the molar mass of copper chloride, and that's 134.5. Then the number of moles in 15 grams is 0.1152, so that's just 15 grams divided by the molar mass. And now we need to calculate the molar mass of copper carbonate, that's 123.5 grams, and then we just need to calculate the mass of 0.1152 moles of copper carbonate, because these react 1 to 1, it's the same number of moles, and that gives us 13.8 grams. How about an example where we need to calculate the mass of product that we expect? How about this question? A student wants to make geranyl propanoate from geraniol and propanoic acid. This is our equation. We're just using the word equation to start with. This is our formula equation. You don't need to know those formula other than we'll need to work out the formula masses. You wouldn't be expected to work out those formula. They would be given. And our question carries on. The student uses 23.1 grams of geraniol and excess propanoic acid. And we need to calculate the amount of geranyl propanoate that would be produced. So our first step is to calculate the molar mass of geraniol, our reactant. That's 154. So the number of moles in 23.1 grams of that is 0.15 moles. Next, the molar mass of our product, geranyl propanoate, is 210. And the mass of 0.15 moles, why 0.15? Again, these react 1 to 1, therefore we have the same number of moles of product. So 0.15 moles of something that weighs 210 grams per mole gives us 31.5 grams. Okay, in summary, what have we learned in this tutorial? The mole is the international unit for the amount of substance. We use moles because we can't react individual molecules. We just can't just use mass because atomic masses of elements vary massively. Okay, we can calculate the number of moles of reactant or product in a reaction, and we can then calculate the mass of reactant required or the mass of product expected. And in our next tutorial, we're going to look at percentage yield.